Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Apply operations to an array, Leetcode 2460. If you are new to the channel, consider subscribing. I try to make daily videos on the problems related to data structures and algorithm, including detailed explanations, optimized solutions, and step-by-step walkthroughs to help you improve your coding skills. Now to the problem. In this problem, we are given a zero-indexed array nums of size n consisting of non-negative integers, and our task is to perform n-1 sequential operations to this array. In each operation, we take two adjacent elements at indices I and I plus 1 and see if the elements are equal. If they are, we double the element at index I and set 0 for the element at index I plus 1. But if the elements are not equal, we skip this operation. And after performing all these operations, we shift all the zeros to the end of the array and return this resulting array. For example, consider the given array. For I equal to 0, we pick up these two elements and see if the elements are equal. They are not, so we skip applying the operation. Then for I equal to 1, we pick up these two elements and compare if they are equal, and this time they are actually equal. So we set the value at index 1 to 4 and at index 2 to 0. Now for I equal to 2, we compare these two elements, but they are not equal. So we continue. Then for I equal to 3, we compare these two elements and they are actually equal. So we set the value at index 3 to 2 and at index 4 to 0. And finally at I equal to 4, we compare the elements at indices 4 and 5 and they are actually equal. But 0 into 2 is 0. And now we are done with all the adjacent pairs in this array. And after performing all the operations, our array becomes 140200. And now we have to shift all the zeros to the end of the array. So in the end, our array becomes 142000. Now in terms of solution, the straightforward approach would be that we traverse through the array and apply the operation for each pair of adjacent elements, just as we did in the simulation step during the example walkthrough. And after performing all the operations, we construct a new array where all non-zero elements from the modified nums array are preserved in their relative order, while the remaining positions in the new array are already set to default value of 0. And the time complexity of this approach will be O of n, where n is the length of the input array. As we go through each element at most twice, once for running the simulation and then for storing them in the result. And the space complexity will also be O of n for using the extra space for the result. The advantage of this solution is that it is simple and does not modify the input array. This can be beneficial in the scenarios where immutability is important, such as functional programming paradigms or situation where the input array needs to be reused without unintended side effects. However, in interviews, interviewers often ask for in-place modifications, which challenges candidates to optimize the space complexity. And this is where we can use two-pointer technique. In first pass, we apply the operation on the array just as we did earlier. For example, after applying the operations on this array, we get following array. And now in the second pass, we use the two-pointer technique. We can use a normal pointer I or read pointer to iterate through the array. And we will use another pointer right to track the position where the next non-zero element should be written. This ensures that all the non-zero elements are shifted to the start of the array while maintaining their relative order, and all the remaining elements are set to 0. Now let's see this in action for the second pass. Initially, both read and write pointers are at the front of the array. So first at read pointer, we read the element is 1, which is non-zero. So we set the value at this right pointer. So here nothing changes as the read and write pointers are at the same positions. However, we will see how things change once read and write pointers separate later. And since we wrote the value here, we move the right pointer forward. And again, we move the read pointer forward to read the next element. And now the read pointer reads the value 4, which is again non-zero. So we set this value at the position of right, that is index 1, and move right pointer forward. And in any case, we will move the read pointer forward to read the next element. Now comes the interesting case. This time read pointer reads the value 0. So right pointer doesn't have to write anything. Hence it stays at index 2 and This time we only move the read pointer forward to read the next element, and right pointer stays at index 2. Then we read the value 2, which is non-zero. So we write it at position of right pointer, that is position 2, and move the right pointer forward. And in any case, we will move the read pointer forward to read the next element. Now the read pointer reads the value 0. So we do nothing and move the read pointer forward. And again it reads value 0. So we do nothing, and now the read pointer reaches the end of the array. So we are kind of done, and now our array becomes 1, 4, 2, 2, 0, 0. But the right pointer points at index 3, which is this one. So from this point onwards, all the values should be 0, because the right pointer has written all the non-zero values based on the input from the read pointer. So this is what we will do. If there are any remaining non-zero elements in this part, they would have already been set on the left side of the right pointer. So we will iterate from right pointer to the end of the array and set all the values to 0. So now our array becomes 1, 4, 2, 0, 0, 0. And this will be our answer. Now the time complexity of this approach is still O of n, as the array elements are processed at most twice. However, the space complexity reduces to O of 1 since the modifications are performed directly on the input array. Now let's quickly go through the code walkthrough of the approach we just took. So again we iterate through the array from index 0 to n minus 2, and for each adjacent pair apply the operations. And once we have applied the operation, we perform the second pass, where we initialize right pointer to 0 and we iterate through the array from start to end using the read pointer I. And for every non-zero element at ith index, we write it to the position pointed by right pointer and move the right pointer forward. And once all non-zero elements have been written in the array, the remaining positions are set to 0 by iterating the right pointer from its current position to the end of the array. And finally, we return the updated array. Now let's see if we can solve it in a single pass. In other words, can we combine the operations and the shifting of non-zero elements into a single iteration over the array? The answer is yes. We can achieve this using the same two-pointer technique. When applying the operations, if two elements are equal, one element doubles and the other element becomes 0. These operations are applied sequentially as we move through the array. And we know that right pointer trails behind the read pointer, ensuring that read pointer performs the operations and reads the value. And if the value at the read pointer is non-zero, then it can be written to the position of the right pointer. Additionally, when the read and write pointers are not at the same position, the read position is cleared by writing a value 0 to it. This ensures that non-zero values are shifted to the front while the zeros are naturally left behind. Now let's quickly see this in action. So initially, both read and write pointers are at the start of the array. Now the value at read pointer at position 0 and 1 don't match, so the element 1 stays as is. And since it's a non-zero value, we will write it at the right pointer and move the right pointer forward. And in any case, we will move the read pointer forward to read the next element. Now the read pointer is at position 1 and it reads the element 2, which is equal to the next element. So we perform the operation, set the value 4 here and the next value as 0. And now the read pointer reads the value 4 and gives it to right pointer, which right pointer writes at index 1 and moves forward. And in any case, read pointer will move forward to read the next element. Now the read pointer reads the value 0 and we don't have to write it, because even if it is equal to the next element, we will double it and it stays 0. And in this case, it is not equal to the next element, so it remains 0. And in any case, right pointer will not write this value. So we keep the right pointer at this position and move the read pointer forward to read the next element. Now the read pointer is at index 3 and we have the same value at index 4. So that means we apply the operation and set the value 2 here and 0 at this position. And now the value at the read pointer is 2, which is non-zero. So we set it at the right pointer. And since we filled in this 2 here, we have to set this 2 as 0 now, because we have already assigned this 2 at the correct position in the array. And now we can move the right pointer forward. And in any case, we have to move the read pointer forward to read the next element. and this time we read the value 0. So we skip this index and go to the next one, and again we read the value 0. So we skip this index and come to the end of the array, and now we are done with all the elements in the array, and finally our answer will be 142000. And again the time complexity and space complexity are O of n and O of 1 respectively, just that we are running this simulation in one pass. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.